What are different types of power devices? Simply, we can call it as a power devices for now, because power electronic devices means it's electronic devices which is handling high power, high voltage, high current. So simply, we can call this as a power devices. So this can be classified into two types: silicon based and then silicon carbide based. And silicon based, we have diodes, transistors, thyristors. These three are the three device families. Under each family, diode family, we have several different types of diodes, which are Schottky diode, epitaxial diode, double diffused diode, and so on, PIN. So, but mostly we will just use general purpose power diodes in this course. So you don't need to worry about these other devices. But I think you have studied about Schottky diode, at least in your electronic course, I assume. Okay, and then transistors. Transistors are really important. In transistor, there are different types as well: BJT, MOSFET, and IGBT, and so on. So in each category, we have some subcategories as well: NPN, PNP, BJTs, bipolar junction transistors. In MOSFET also, we have PMOS, NMOS, conventional, SFET, cool MOS, and so on. But basically, if you know the operation of one transistor, especially in the MOSFET, if you know about MOSFET operation, then all the operation is similar. The working principle is similar in other types of similar MOSFET family transistors. So MOSFET means what? Metal oxide semiconductor field effect transistor. This is actually very important component in the electronic industry. MOSFET is useful in power electronics, power MOSFET. The same MOSFET is also useful in digital electronics. You know, all the ICs, integrated circuits, the one you're seeing in your mobile phone, the chips, in your laptops. So all are based on this MOSFET principle actually. So this metal oxide semiconductor, it's having P type and N type. It's based on the impurity we are adding in the silicon. So based on what type of impurity you are adding, so we can classify into P type and N type. So P type, the majority carriers are holes. In PMOS, we can simply call as a PMOS. We don't need to call P MOSFET. So here holes are the major, that is the plus, and the electrons, that is a minus. Electrons are minority carriers. This is the majority carriers. So majority and minority carriers. And the NMOS is the opposite. In NMOS, electrons are the majority carriers. It looks like a smiley face or a sad face. Okay, and then holes are minority carriers. So if we go into more details, then we have to go to the device physics. I think you have studied about this device physics, how the electrons are traveling in the outer orbit, and how, when we give the voltage, there is the force, how the electrons are moved from one atom to another atom, and that is the electricity, that is the current. So I think we are not going to into the physics and how the electrons are moving and so on. But the MOSFET concept is the same MOSFET, just we are changing the impurity levels and the impurity types, and we are classifying into different types, because each type of transistor has its own conductivity level and the gate voltage level and so on. And the IGBT, it's also another type of transistors, and it has some subcategories as well. Thyristors. Thyristors are most important in these power electronic devices or power electronics. We are using these thyristors in many of the converter circuits because thyristor has some special properties. So you can turn on, you can achieve controlled turn on under this family, thyristor family. There are so many different devices are available. For example, here fast thyristor, GTO, IGPT, IGCT, MCT, MTO, and so on. So we are not going to see everything. I will explain one thyristor working principle completely and the VI characteristics. The other thyristors are also following the similar working principle. Please note down my word. I did not say same working principle, it's similar. So once you know the working principle of one device, the similar principle is applicable in other devices as well, but it can vary slightly. And the silicon carbide, yes, we are also using that, but that is used for some special purpose applications. So we don't need to worry about this silicon carbide. So mainly we are using these power diodes, power transistors, and power thyristors. Actually, this flow chart, it looks little bit complicated. So here is the simplified one. So here we can classify the power devices into three categories or three types. That is diodes, thyristors, transistors. So diodes, we have general purpose diodes, high speed diodes, Schottky diodes. Thyristors, we have also different types or further classifications. So SCR, GTO, GAT, SITH, RCT, and so on. So out of all these thyristors, SCR is the most important one. So that is what we are going to see. We will also see the power diode. So SCR means silicon controlled rectifier. So we will see first of all, what is SCR and how it works. How can we turn on and turn off the SCR by controlling the gate voltages and so on. And what is the VI characteristics of this SCR, voltage and current characteristics. Actually, in practical, we do not call this as an SCR. We just call this with a family name, thyristor. So generally, when we call thyristor, it indicates SCR. So you can imagine that much we are using SCR. Of course, the other types of transistors is also thyristor family, but they have their specific name. We call with a specific name, but SCR we generally simply call as a thyristor. Okay, transistors, again, this SCR can also come under this family, transistors and MOSFET, IGBT, and SIT. So these are the devices and these are the symbols of each device. So diode, you know already how we can symbolize the diode. And this is the IV characteristics or VI characteristics of the diode. So for each device, here you can see the symbol and its VI characteristic. So maybe you can practice by yourself at least some important devices and its symbols. And also you can try to read in the textbook this VI characteristics, how it works. But I will explain about this diode and the thyristor. But I encourage you to read the textbook. If you cannot read everything, but at least you please read the important devices which you are going to use very often in practical experiments. Even after you graduate, if you work in industry, if you build or if you design power electronic circuit, you will be using these devices. So maybe you had seen this in the electronics lab, right? This is the typical PN junction diode. So power diodes are a little more different, and some power diodes can look like this. How do you see here? You can see the different types of diodes, how it looks in practical, because it has to withstand high voltage, high power, high current. So the appearance is totally different from the general purpose diodes. And these are practical thyristors. So you can see thyristor, this is how it will look like. So it will have 3 leads because it's indicating 3 terminals, including the gate terminal. So this is what you are going to use when you build the circuit. Maybe you will use the PCB, you will solder it, or you will use the breadboard. And these are GTOs, and they will look like this.